Hello everyone, welcome to the solution of LeetCode problem 190 named reverse bits. In this problem, we have to reverse the bit of an unsigned integer. That means, suppose this is our given input, which is in the 32-bit format. We have to reverse all of the bit also in the 32-bit format. This is the simple plain explanation. Now let's move on to the algorithm. Before going to the algorithm, let's try to understand what actually the problem says. Here, the problem says we have to reverse the bit. Suppose our bit is 0, 1, 0, 1, and 1. Now, if we reverse it, it will become 1, 1, 0, 1, and 0. So, to understand this algorithm, we have to make the concept clear of these four concepts. At first, left shift, then right shift, then bitwise and bitwise OR. So here, what basically the left shift operator do? The left shift basically shift each of the bit left side by one position. Suppose our bit is 0, 1, 1, 0. And if we perform the left shift, the bit will be shifted one position to the left side and it will become 1, 1, 0, and 0. That means all of these three bits will be shifted one times into the left side. Similarly, for the right shift, if our bit is 0, 1, 1, 0, then we will shift it right by one times. So we will shift each of the bit to the right side. So it will become 0, 1, 1, and here it is 0 by default. These three of the bit will come into these positions. So it is the concept of right shift. Now, bitwise AND operation. So here the bitwise AND operation is very simple. Suppose we have two variables A and B, and there will be 4 combinations available. Now, the bitwise AND operation will be 0 and 0 will be 0, 1 and 0 will be 0, 0 and 1 will be 0, and 1 and 1 will be 1. That means if both of the bits are equal, the bitwise AND operation will be equal to those bits. That means 0 and 0 will be 0, and 1 will be 1. Now the bitwise OR operation will be 0 and 0 will be 0, 0 and 1 will be 1, 1 and 0 will be 0, 1 and 0 will be 1, and 1 and 1 will be 1. That means here, if any of the bits is 1 between the first two bits, then the output will be 1. So this is the basic concept of this 4 term: left shift, right shift, bitwise and bitwise OR. And we will use these 4 concepts to solve the reverse bit problem. Now let's see how can we do it. Now here we have to reverse this bit and make the result. Now the input is given in the 32-bit manner. That means we are given 32-bit and we have to reverse each of the bit. Suppose if this is our input, the last 4 bit is 1010, and if we reverse it, it will become 0101 after all of the 0 will be placed. That means this is the reversed bit version of the input. But the question is, how can we find this bit? We can simply find this bit by using the 4 approach we have described earlier. At first, suppose it is our resultant array and all of the element of this array is 0. By default, it has 32 bits from 0 to 31. Okay, so far so good. Now we have to take the last bit of the input n. So how can we take the last bit of the input n? Because we have to take the last bit of the input n and place it to the corresponding positions. So here we can find the last bit by using and 1 operation. Because if the last bit is 0, then means 0 and 1 will be 0. We will find the last bit. If the last bit is 1, it will become 1 and 1, which will be 1. That means we will again find the last bit. So here the last bit is 0. So we will place the last bit into this position. Now, to place the last bit here, we will apply the OR operation. Here, the initial bit will be 0. So 0 or 0 will also be 0. So we have to add 0 here. Now, as we have completed iteration of this bit, we have to look after the next bit. So how can we look after the next bit? Here, we can use the right shift operation. So if we right shift this all of the bits by 1, this last bit 0 will be discarded and it will become 1 0 1 0 and so on. So the right shift operation will be placed here. Now we have to again take the last bit, which is and 1 operation. Now we have to place it into the last position of the corresponding result, but unfortunately it has already 0, so we have to shift 0 by 1 position. So it is another shift. Now if we shift 0 by 1 position, the 0 will be placed here and we will apply or add 1 into this position. Similarly, we apply a right shift here and it will become 0 1 and 0, and this 1 will be discarded. Again we will make the left shift here, so all of this 0 and 1 will be shifted by 1 time and this last bit 0 will be placed here. Now again this will be discarded and we will again right shift these 2 bits 0 and 1. So the 1 will be placed here. So again we will left shift all of the bit. Now 1 will be placed here. So here the algorithm is pretty simple. As we have seen that we have all of the remaining 0 as a prefix. So if we apply the corresponding operation into this 0 as well, finally the array will become, or the bit will become 0 1 0 1. Then there will be remaining number of zeros as well. So we have seen that we have applied 4 operations. The first operation is finding the last element. Here we applied the bitwise AND operation. The next operation is bitwise OR operation. We applied the bitwise OR operation to replace the bit into the resultant array. Now we have applied 2 shifting operation. One is left shift, another is right shift. the right shift operation placed into the given input to always find the last bit to make the consideration, and the left shift operation always placed into the resultant bit because we have to make the room or space for the next iteration. That's why we have to shift all of the bit left side by 1 times. That's why we are applying the left shift operation into the resultant bit. Finally, by applying this operation simultaneously, we can reverse all of the bit. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named reverse bit, which has an input and as a parameter. Now, initially our result is 0, and we are running loop from 0 to 31. And here, to make the room for this iteration, we are left shifting all of the bit by 1 times. And we are taking the last bit of the AND by using AND operation. And we are inserting this bit into the result by using OR operation. And finally, we shift all of the element or all of the bit of the AND into the right side by 1 times by using this divided operation. Finally, we have to return the result. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.